2 plus the cube root of x over the cube root of x. So every time in math we start a problem, in the back of our minds we have to have simplify. These words have to be continuously active in our minds. Simplify, factor, make your life easier. Make it easier. Make it the problem as easy as possible. So when I look at this function, because this is the integral, the indefinite integral from this function dx. When I look at this, I realize that the denominator has only one quantity. 1. It's not the cube root of x plus 4. This is terrible in the denominator. But it only has one term. I shouldn't say term, it's not a polynomial, but one quantity. I like it. The reason why I love it when the denominator has only one quantity is because I can separate the ratio into how many fractions? Exactly, because I have two quantities here. Exactly. So 2 fractions. And here's how I do it. 2 over the cube root of x plus the cube root of x over the cube root of x. This is very nice and easy because it's 1. And this we worked on before. How do you present this so it makes it easier? I think someone wanted to say something, but I didn't hear anything. My apologies.
Is it x? I want to say like x to the third or stop. 1/3?
Yes, but with minus. Because it's coming from the denominator. Awesome. Is that clear why it's minus?
Yes.
Perfect. Awesome. That's what I'm going to do. I refuse to work with this. I don't even know what to do with it. Other than simplify it, make it easier. So you know me, I'm lazy, I don't want to copy that. So jump over all this. So this is the integral from 2x to negative 1/3 plus 1 in parentheses. It must have parentheses dx. Here parentheses are not required. It's a fraction. But here I have to. So now it becomes a piece of cake. When you look at this, I say, oh my goodness, what do I do with this? But once you understand that you can make it easier, you can simplify it. If factor is not here, we didn't factor, but you can simplify it and make it easier. Okay? So now this is a piece of cake. So now I copy 2, it's a constant, and then I need to determine the function that when I differentiate, I get this. So how do we use the power rule? What did we say last time? Anyone remembers? I know you were thinking about the test, so maybe you were not paying attention. I can repeat it, or if anyone wants to help. It's okay if you're wrong. Anyone?
I'm looking at my notes. And
Yes.
My notes is going to be the one that has the xm to the +1, right?
Yes.
Okay. So would it be x to the 1/3, negative 1/3 plus 1?
Exactly, which is 2/3, and you don't have to calculate it again. Great job. Perfect. Plus, now I have to think, which function prime gives us 1. And that's easy. There is only one function that we differentiate and we get 1.
X.
Exactly. And of course, I cannot forget what?
E of X.
Constant.
Exactly. This prime is this. This prime is this. But there is always a 0 in there. This prime is this. I have to clean this up a little bit and flip. 3 over 2 times 2 will be 3. 3x to 2/3 plus x plus c. Also the c, remember, is always there because this symbol, dx, represents the most general antiderivative. So c must be there. It's a family of functions, infinitely many functions, whose derivative is this. Guaranteed. Awesome. Can we move on now? Do we feel a little bit better about this? Yes? No? Okay, moving on then. So the next question, the next section is 4.2. We're going to talk about areas. And you can say areas, well, who cares? And I introduced this idea last time. That's why I didn't recycle this just yet. I will explain again. But that's why we're talking about to get to this and get again to this. Okay? So the sum of areas, adding areas, or the sum of areas. So we can look at the sum or this. Same thing, stretched. Okay. So now let's look at areas. And why? First of all, why? Again, why would I care about areas? Here's the reason why. Assume that I have the velocity. Let's say this is the velocity function. Between 0 and this is t, and this is v of t, velocity. So let's say between 0 and 10 hours. So this is in hours. I have the velocity function, I graph the velocity function, and now if I determine this area somehow under the graph of the velocity function between time t equals 0 and time equals 10, this area represents the total distance covered. Total distance covered while I drive between 0 and 10 hours. But how do I determine this area? That's the question. Okay, so let's take a very simple example. Let's say f of x equals x squared plus 1. Let's pick a very simple interval. Let's say 0 to 4. And what is the question here? Question. Find the area. I'm going to write in parentheses, approximate the area, because we cannot, right now, we cannot find the exact area. We cannot. We will in the next probably half an hour. But right now, we can only approximate the area. Find the area under f of x on 0, 4. Find the area under this function between 0 and 4. Just find the area. Well, I'm going to graph it. Here's the graph. If you remember, this is x squared. So this is x squared, but I have to move 1 up. Up 1. Good. So when x is 0, y is 1. 1, 2, 3, 4. So at 1, plus 1 is 2. At 2, 4 plus 1 is 5, and so on and so forth. So let's say I have this graph, and right here is 4, 16, 17. I want to find this area. Okay, what I'm going to do is continue here. There is one more piece of information. Find the area under the graph of x squared plus 1 on the interval 0, 4, using 4 subintervals. If you don't like the words subintervals, use partitions. If you don't like the words subintervals or partitions, you just use pieces. Okay? Subintervals. Okay. They have to be equal in width. Okay, 1, 2, 3. So this is my first piece. Here's my second piece. Here's my third piece. And here's my fourth piece. So this is the first one. Here's the second one. Here's the third. And here's the fourth. Later on, we're going to say, so the number of intervals is normally denoted by lowercase n. So n equals 4. 4 subintervals between 0 and 4. X, f of x. And here's the function, f of x equals x squared plus 1. We have several options. In this class, we only look at two options. Using the leftmost point, or we're going to do both, the rightmost point. Again, what are we trying to do? We're trying to find the total of something. If this is velocity, I'm finding the total distance. If this is the rate of change of profit, for example, if this is p prime of x, finding the total area will give us the total profit. So if this function is p prime of x, then this whole area will be the total profit. If this is the marginal cost, finding this area will give us the total cost, and so on and so forth. Okay, now let's establish what the leftmost point means, and let's establish what the rightmost point means. I'm going to graph it again. I'm not going to put anything else on that graph. Leftmost point, rightmost point. I'm graphing the same function again. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Good. Leftmost point. I divvy up again 4 equal pieces. The leftmost point means I'm using this height and I create a rectangle. Leftmost point, I'm using this height and I create a rectangle. Leftmost point, I'm using this height and I'm creating the rectangle. Finally, for the last one, the fourth one, I'm using this height and I'm creating a rectangle. Obviously, I'm missing a lot. So this is an estimate, it's an approximation, but I'm missing this piece, I'm missing this piece, I'm missing this piece, and I'm missing this piece. So this will be definitely an underestimate. Underestimate. Let's see what we get. It's an underestimate, but let's see what we get. So, the area with 4 left is base of the rectangle times height. But the base is the same in all of them. It's 1, 1, 1, 1. So I'm going to say 1 times. Since I'm looking at the leftmost point, f of 0 plus f of 1 plus f of 2 plus f of 3. I cannot have more than 4. So base times height plus base times height. But I put it out, I put the 1 outside. I should have written 1 times f of 0 plus 1 times f of 1 plus 1. There is no need because 1 can stay outside. Base times height, f of 0, plus base times f of 1, plus base times f. How do I know? This is 1, this is 2, this is 3, this is 4. Plus base times f of 2, plus base times f of 3. Let's see what we get. Remember the function was x squared plus 1. Let's stop for a moment. Any questions? Can you follow this? Is anyone with me?
Yes, I'm following it so far.
Okay. So f of 0, 0 plus 1. So there is no point in writing the 1 in front. It's 1. F of 0, 1, plus f of 1, 1 plus 1, 2, plus f of 2, 2 times 2 is 4, plus 1 is 5, plus f of 3, 9 plus 1 is 10. So 10 plus 8. The area under this graph, which is an underestimate, I'm missing these 4 pieces, is 18. So using 4 subintervals, using the height of the leftmost point of each rectangle, yes, we get 18. Now let's try the rightmost point. Okay, I do exactly the same, but this time is base, and the height is here. Base, the height is on the right. Create the rectangle. Base, the height is on the right. Create the rectangle. And base, the height is on the right. And create the rectangle. Is this an underestimate of the exact area or an overestimate of the exact area?
Over.
Absolutely. Because I have some piece here, another piece here, another piece here, and they are not, these pieces are not under. So this is an overestimate. Fine. The truth will be between this and the overestimate. And we will determine it exactly shortly. Okay, so the area with 4 right is still 1, but this time I have to start at 1 because the height is on the right. And then f of 2, and then f of 3, and then f of 4. Only 4. Please make sure you don't have 3 or 5. It has to be 4 because n is 4. So we have f of 1 plus f of 2 plus f of 3 plus f of 4. I already have these numbers, not 1, but 2. So I have 2 plus 5 plus 10 plus 16 plus 1, 17. So the answer is 17 plus 7, 24, 34. I know for sure that the exact area is definitely greater than 18 and is definitely less than 34. So this is our estimate so far.